go ahead and clap. No problem.
Thank you.
So we are coming to the last paper for this session. I think one of the longest number of papers in a session I have attended in Sigmod for a while. This talk is on Skyline community search in multi-valued networks. And the authors are not present here, so Dran Ouyang is going to present on behalf of the authors.
Good afternoon. Today I will give a presentation about the community search in multi-value network. And at first I will give the introduction about the community multi-network. There are many networks in our real life, the web graph and the social network and the role network and the intentional things network. The multi-value network, it means for each node we associate with D attributes. Such as the similarity influence. Here is an example of the network which have 6 vertices and 3 attributes. Why we should use this multi-value network? It means that if we want to find a community which is high influence group and has the similar research introduced to me, we can't give only single attribute to each vertex. Here is an example of 2 attributes. So the existing solutions such as the cohesive subgraph for the community detection and the influence community model cannot serve the multi-attribute community problem. It can only serve the single attribute. Here we give the model how to do the community search in the multi-value. The multi-value is for each node associated with a d-dimension vector, and the community is for each dimension we select the minimal value in the community. And in the Skyline community, we give 3 constraints. At first, it should be a connected K-core. So the community which we detect, it will be a cohesive subgraph. And the next is the community should not be dominated by any other community in the Skyline. And finally, it should be a maximal community. If we don't find the maximal community, the result will be exponential. So here is an example. And if you want to find the 3 vertex, V1, V2, V3 is a Skyline community which have the value 8, 14, and 3. And there are 2 challenges. The first is the space is too large. The number of the connected K-core is exponentially large. And the second challenge is that in the traditional Skyline problem, the data point is present. And here, when we want to find the community, we can't get the data point, and we should search in the program. So at first, I will give the basic algorithm, which is 2D for the problem. 2D algorithm has 2 steps. At first, we just fix 1 dimension and to invoke the one dimension algorithm to compute the optimal K-core. And when we finish the 1D algorithm, and we can constrain and pruning the unpromising nodes and recursively to invoke the 1D algorithm. And just like the figure on the left, if we fix the first dimension x1, and we can get the maximal vertex, which is h3 in the 1D algorithm, and then we delete all the community which is dominated by h3, and search the second community h2. By the way, but this algorithm is not efficiently enough, and the time complexity is too large. And we can also extend the 2D algorithm to the multi-valued network, which is D larger than 3. Because of the efficiency, this paper proposed advanced algorithm, which is called the space partition algorithm, which is much efficient than the basic algorithm. In this algorithm, which has 4 steps, it also should first dimension, just like the basic. And if we fix one dimension, we can compute the maximal value for this dimension. And then we got a dimension -1 problem. And how to solve the D-1 community is just we need to create a priority queue to organize the subbase, which is D-1, based on the F1 value. And when we pop the base subspace, we recursively to use our algorithm in D-1 dimension. And the final step is when we partition the the search space to a set of overlap regional subspace, then we can go to the step 1 and do it recursively. Just like the figure on the left, when we got 4 vertex C1 to C4, it's hard to calculate the skyline follow this skyline which are not dominated by the 4 vertex. We should divide this 2D this space to 4 parts by the 4 vertex, just like the C1. Just like C1 is the subgraph and subspace, and C2 subspace to C4. Make it to 4 regional subspace. So this algorithm, the time complexity is much better than the basic problem, but it have more space complexity. Here is a trade-off of the traditional problem. And our experiment is on 4 data sets. And we can find that when we vary the K, which is the cohesive parameter, the new problem is much quicker than the basic. And if we vary the dimension D, when D is 2, they have the same efficient because the new problem can't solve the 2D problem. The D is larger than 3, it will be better. And if we vary here is the result, we vary the scalability. And here is the case studies. Finally is our conclusion. We proposed a community model on the multi-valued network, and we give the basic and advanced problem. Finally, we extend the experiment. Thank you.
Will you be able to take questions? Or you're sure? Okay. Any questions for him? He's not the author. It's up to you. Yeah. Please. Don't ask too hard questions.
Could you explain a little bit more about this example use case?
You may want to know the algorithm 1 over algorithm 2.
So he is asking you to explain the details of
what you have observed.
Use case.
Yeah, yeah. The result of use case.
The
Last slide.
Yeah, that's the one.
What do you mean?
In this use case, when we select a vertex, and at first we should make it to a k-core, which is k is larger than 4. Oh, sorry, it's too difficult to explain.